Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is about carboxylic acid. You can see this is acetic acid. Actually, three-step reactions have been carried out on this, and you have to say that what is the major product of this reaction. Here, four options are provided and one of them is the right answer. So student, I request you, this is an easy question. Please try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. And don't worry whether your answer will be right or wrong, because self-evaluation is essential for improvement. That's why you should try. So I believe you have tried by yourself. It's my turn to give you the right answer. So student, when such kind of multiple step reactions are provided, I always suggest that student go step by step. First, look at the reactant. It's pretty easy. Acetic acid. And first step of the reagent, start in this way. So the first step, this acetic acid, it has one alpha proton, and reaction is red phosphorus with chlorine, means SBZ reaction. It will produce this alpha chloroacetic acid. Fine. So in the next step, it is sodium nitrite and sodium carbonate. Student, this monochloroacetic acid is more acidic compared to simple acetic acid, and sodium carbonate is actually base. So you can expect that simple acid base reaction means, in this case you can see this salt formation, or more specifically if I say sodium salt formation of this carboxylic acid. One part is gone. Second part, here one reagent is given, sodium nitrite. If you look at the nitrite anion, this nitrogen has one lone pair of electron, and actually it can act as nucleophile from both sides, from nitrogen and oxygen, but this nitrogen center is relatively softer in nature, so it will undergo nucleophilic substitution reaction or SN2 type. And these alpha halo acid, you can consider it's a category of alpha halocarbonyl type, so it will leave and ultimately it will produce this. And remember, alpha halocarbonyl can undergo SN2 reaction more efficiently. I've already discussed a dedicated lecture on this. Now in the next step, so one side is carboxylate, another side is nitro, so we can write this thing in a different way. So different way means, you can see here, why? Because there is a phenomena of decarboxylation of beta keto acid. So beta keto acid decarboxylation, please recall I've already make a dedicated lecture on this topic. So what happened, they undergo facile decarboxylation. Fine. Now in this case, actually you can consider that this position is alpha, this position is beta. So this part you can consider beta keto acid type. So chemically you may expect that their behavior that type. So now you will say that, sir, here note beta, here in double bond O. It's true, but remember it is in resonance, means it can push, it can open. So this is actually this NO2 this group is in resonance, so that's possible. Now in this case what happens, so you can see that these O minus can abstract this proton, it come here, it will open up, come back, and it will come here, this position. Okay, so what it will produce, so this side is OH and obviously this is minus. Now this actually pretty stable molecule, because you can see there's negative charge on carbon. Is it stable? Yes, because the group is nitro. Okay, we'll discuss little bit later on. Now here you can understand this is OH and this is negative. So what can happen, these hydrogen could be shifted from here to here, and what it will produce, this compound, and it is called student nitromethane. Okay, or you can say the first member of nitroalkane series. So this overall reaction, you can consider that conversion of carboxylic acid to nitroalkane using these many steps of reactions. Now in very short, if we consider the key steps and name reaction, the first step is HBZ reaction, this hydrogen is replaced by chlorine. Second is SN2 reaction and neutralization both. So obviously this NO2 nitrogen act as nucleophile and undergo this SN2 reaction, and obviously sodium carbonate is acting as a base to produce this sodium salt. obviously countercation is sodium. Now these salt can undergo fissile decarboxylation by beta keto acid decarboxylation type pathway, and it will produce these, you may consider this moiety, means proton shifted moiety, which undergo tautomerism, and obviously it will produce this nitromethane molecule. Now what is the right answer here? Nitromethane. Option C is the right answer. Now if such question appears in your exam less than 30 seconds, how can you come up to the right answer? In this context, student, you need to think little more. For example, lead phosphorus, chlorine and this carboxylic acid results in alpha chloroacid. I suggest you, student, you write this part. Now second step, look at this is NaNO2 sodium carbonate in water. So NaNO2 can act as a base, so neutralization, this carboxyl part will be there, and another thing, this chloro will be substituted by nitro. That thing you understand. Now this part if you understand, then picture became little easier. Okay, now simple thing, that this is NO2 carboxylic acid. Okay, fine, this much amount we gone. Now what is the third stage? Third stage is, okay, obviously here should be Na plus. Third step is heating an acid, so obviously decarboxylation will happen. So heat an acid. So in the first step these option gone, okay, and water and heat, so these amine also gone. So now competition is in between option A and option C. Now simple, when you do workup with heating and beta keto acid type, so this compound will instantly convert into this via decarboxylation, means carbon dioxide elimination. So that's why this is the answer. But student, it's pretty easy example, so I think this much amount of hard work may not be needed. Okay, so in conclusion, what you have learned today, that H with Z reaction convert carboxylic acid to alpha halo carboxylic acid. Here actually we are using red phosphorus and chlorine, or even PCl3 can do this job very well. Now alpha halo carbonyl compound can undergo fissile SN2 type reaction due to the conjugation with carbon, means carbonyl group more specifically, and alpha nitrocarboxylic acid undergo fissile decarboxylation like beta keto acid derivatives through a 6-member cyclic transition state. The mechanism I have shown. I have already made a dedicated lecture, you may visit for further understanding. Now this method for conversion of acetic acid is actually a very good to prepare the first member of nitroalkane, that is nitromethane, and these nitroalkane, student, alpha proton is significantly acidic, as telling its pK closer to 10, means it's comparable to active methylene compound. For example, if I say acetyl acetone, so these protons are significantly acidic because they are in between these two carbonyl groups, so conjugate base is doubly resonance stabilized. So these nitroalkanes acidity closer to them. Okay, and this property is utilized in nitroaldol or Henry reaction. I have already discussed dedicated lecture on this. Please visit for better understanding. So this is the end of this question. I thank you everyone for watching this video, and if you really enjoy and consider the content of my channel is worthy, then please help this channel to grow. So stay happy, stay blessed. See you in my next